in the data science community, notebook frameworks like Jupyter are gaining rapidly popularity these days, and there are also standard ways to access and pull data from databases. But they mostly ignore capabilities of SQL and in particular built-in analytic routines. So I'm going to show you now a way to make this possible in a very natural way for notebook users. So this is working in Bluemix with the analytic services and -db. So we go there and we first open a notebook in the analytic user experience. There we first import some packages that provide us this pushdown capability for the notebook, in this case Python, and that enable us to do a very simple connect to -db like we can see it here. For this demo we have a table that has 100 million records. And the first thing that we attempt to do here is to just load it as a standard pandas data frame in Python. We immediately get the warning that this will take hours just to load it into the pandas data frame, and we don't even know whether it will fit into memory in Python at all. So this will get us nowhere and we will cancel this attempt. And instead we will use the pushdown data frames from our package that look exactly like pandas data frame, providing the same API and same user experience. So we can do, for instance, some standard operations like sampling the data and looking at a set of records, or looking at things like how many records do we have in the data frame at all. But we can also do some statistical calculations, like in this case we want to calculate correlation between a set of columns, how strongly they are correlated, or we want to do some simple aggregation like the average that we see here. All this is pushed down to run in the database. Also more complex things like, for instance, the partitioned aggregation that we see here in this example that we run, and this is all real time what you see here, and then we can immediately take the result and, for instance, create a nice plot of that. Now let's become a bit more sophisticated. We do some predictive modeling. In this example, we create a k-means clustering model on our data. Here we press the fast forward button, but not for very long. After just 37 seconds, we have our result, our model. Now let's take the model and use it for some prediction. Again, a bit of fast forward, but only after 23 seconds we have our result. So this means we are fully in the active mode and we stay there. We can do further things like, for instance, looking at the model content itself in a numeric way, but also using the power of notebooks to, for instance, plot the model content like you can see it here.